How's everyone doing? Good, awesome, cool. So we're gonna hop in. So my name's Aman. As Jeff mentioned, we've done a course with deep learning AI on evaluating AI agents. I work at a company called Arize. We help some of the largest tech companies out there building with AI, building agents, understand how their applications work and how their agents work, and help them run evals on those agents. The tools we're going to be talking about today are actually all open source. So we have an open source tool called Phoenix. You'll see some of those in later slides. I'm going to apologize in advance because we are going to run a little bit quickly through the first half of the slides. The good news there is that a lot of the first half is actually from the course that we did with deep learning AI. So it sort of sets the context for what does it look like to build and evaluate an agent. And then the second half, we're going to talk about a little bit of prompt optimization for evals and how to build prompts that are robust. It's going to be hands-on, so if you have your laptops, there'll be links so that you can follow along as well. Cool. And with that, let's hop in. So evaluating with vibes. We've all been here, right? We've all been this guy or this person writing an AI agent, about to ship something, and you can kind of tell on his face, he doesn't really feel good. This is actually ImageGen, by the way, Google's new image model, really good. And I think the concept here is, look, I think everyone is just trying to get something out there really quickly. So it makes sense. You look at a couple of examples as you're about to ship a chatbot or about to ship an agent, and it looks good to me, right? Like it's fine. But what I want to introduce today is sort of a term we're starting to use a little bit more. Bear with me, I'm going to introduce it. But what if instead of evaluating with vibes, we were thrive coding instead? And you can see that this person looks way happier, and that's because he has metrics on his screen. He's actually looking at data while he's writing code and making decisions. So I think it's time to go from vibe coding and shift to thrive coding. That's my hot take. Vibe coding was just so last week. So cool. So what is the difference between these two things? So I actually do think that when you're writing code, you're vibe coding. I think that there's this concept of going from subjective versus empirical. That means like looks good to me to something that's a little bit more robust from a metrics perspective. You want to go from more data as well, because eventually, when you're shipping something, when you're shipping an AI app that's meant for your friends or for yourself, 5 to 10 rows of data might look good, but what happens when you have 100 users using the app tomorrow, right? So how do you build a system that scales with you from an evals perspective? And then you want consistency instead of subjectivity. So that's sort of the three principles we're going to be talking about. The examples I'm going to go through as well, they're sort of meant for a general AI agent. So you can kind of think of some of the frameworks and the tools that we're using to be sort of, and you can interpolate those for your own use cases as well. So don't get too stuck on the specific example as we go in. Okay, so let's take a first example. Let's take the new sort of travel agent here, right? So this is, what does it look like to actually go use a travel agent in this sort of new world? This agent might take inputs from a user, like through a chat interface. The user, might have, there might be some prompting underneath the hood to create, maybe some memory even to create a personalized experience. And then this agent can actually take action. So these are the three components we're kind of thinking about when we think about agents. There's some input, some interface, there's some prompting or reasoning or memory, and then there's tool calls or API calls. So we're going to break this down a little bit further into the three components that we sort of think of when we look at evaluating AI agents. The first is the router. So the router is the component that does the sort of bulk of the reasoning of determining what do I need to go do based on some question. So for instance, a user saying, book me a flight to San Francisco. The first thing you might want to ask is, well, when do you want to book this flight, right? Do I need to ask follow-up information, or do I have the information that I need? This is where the reasoning component sits and kind of makes decisions for what to go do next. Next up, we have skills or execution and branches. That's the logic chain, which is basically, do I need to call a specific API or construct an API call in some way? And then there's the memory state, which is the actual data that's being put into the system itself. So it's like, do I need specific information from the user that I might already have stored upstream in my conversation somewhere else in the history? So when we think about the components of the agent, what I would kind of view this as is like, basically the router is essentially determining which skills do I go use next. So pretty simple. Right off the bat, it's determining which skills do I use based on the user query. Once you figure out which skills you need, for instance, there might be multiple API calls. Those can actually be called either in a loop or in a graph interface, in a graph sort of format. This is really up to you to determine, right? So a lot of the logic structure is the sort of secret sauce of your agent, which is how do you want these tools to be accessed? Are there LLM calls? Are there API calls? Is there application-specific code that you want to evaluate? And then sort of last but not least, this is the memory component, the shared state that can be accessed by each component in the agent. The reason I'm showing the memory in this format is because that same data is basically what we're going to get into with our lab as well for how to extract the data from your application to use it in evaluation itself. So that's what we call tracing your application. So these are the three systems. Let's talk about the three components of the system. Let's talk about how we want to go in and actually evaluate the system. So when it comes to the router, this is somewhat straightforward, right? Like basically determining, did the agent actually use the right reasoning or the right logic to pick the skills to perform the task. So you can actually use ground truth here, right? Like if you are asking this question, and we'll kind of go through this with the example. If you ask a question and you say, you should use these skills to actually answer the question in the first place, that's a label that you can use to actually evaluate the first upstream part, the router itself. So for instance, if you pick the wrong skill, like maybe in this case it's parameter extraction, that might be incorrect. You can actually have that as data that you're going to use for evaluation. Next up, you have the skills and the function calls, the API calls themselves. A skill is basically how you want to construct multiple API calls together or a tool. So this is actually, in this case, a RAG skill might actually have 3 calls underneath it, like embed the user query, do a vector DB lookup, and then actually use that retrieve context in the LLM call. You can construct all of this in a function call. We'll do some questions at the end if that's okay, just to kind of get through. So you can actually construct all of this together as a RAG skill that the agent can then go use. So this can be a sort of function that might have multiple parts to it. And then when it comes to the memory and the path, basically for how to solve a given task, this is convergence. We cover this again in the course, but this is actually the number of steps that the agent needs to take to solve a given problem. So you don't want this agent, for instance, a negative example here would be if the agent is kind of going in a loop or recursively saying, oh, I need more information. Let me go further back upstream. Let me try and get information from the conversation history. That's going to lead to a bad user experience at the end of the day because the agent is taking forever to respond. I think we've all been there with chatbots, with customer support agents where it's like, please provide me more information. And then you give it information. It's like, sorry, I didn't understand that. This is an example where the agent is being inefficient. Okay, we're going to get into the technical portion now. So on the left-hand side is a notebook. If you want to pull that up, there's a link at the bottom too. It's bit.ly/Arize AI Dev. And then on the right-hand side is the tool that we're going to use to actually visualize the information from the notebook. So this is Phoenix. This is our open source. You can host it yourself or use our cloud instance. The idea here is really we want to kind of give more tools for developers to understand how their applications are working. And so, feel free to self-host it, or we're happy to chat more about your usage as well. I'm going to hop into the notebook, and let me zoom in a little bit. Okay, so this notebook is actually taking lessons 2 and 3 from our deep learning course as well. So if this feels like it's going fast, you can feel free to reference that. But what we're going to do in this first portion of the notebook is actually construct an agent and point it to a set of data that we have. In this case, this is sales data to answer questions. So think of this as like, you have some data store of like sales data of how people might be, buying a given product on a marketplace. So we're going to do the setup. I've already set this up, but this is what the data looks like. So it's like store number, SKU, product class, information, how many were sold. Great. You're going to import your packages and libraries and set up your Phoenix collector endpoint. So this is basically how you get set up with where should your data start being sent from when you're actually running the LLM in the first place. You'll provide your Phoenix API key, which you can get from the Phoenix application. So once you've logged in and created an account, you can get an API key from here. And you'll just give us a project name so we know how to set up your data. Okay, the next step is instrumentation. Instrumentation is pretty straightforward. Think of this as basically, how do you actually understand what, when you're making application calls, what do those calls look like? So it's sort of constructing, if you're familiar with Datadog or being able to create logs from applications, this is that same concept, but for AI applications. So it takes attributes from those application calls and constructs them in a way that we can visualize them in the UI. Define your model. You might want to test it here. Maybe we'll just run a test call. See if this works. Okay, great. So what I just did was I tested a quick chat completion here. Tell me a short joke. And you can see that that actually appears in my Phoenix project here. So I can go in and click this and see the same input I just provided. Tell me a short joke with the, not a very good joke, honestly. Maybe we should eval for humor. So this is what the Phoenix UI looks like. So it's good to get familiar with input, output, and then what are some of the things you might see, like token information, latency, and then sort of other timing information as well. Okay, now we're going to get into actually building the agent. So let's assume we have this user that is basically asking a question, and there's a router that's calling out to different tools. So we're going to be evaluating here specifically, were the right tools called for the agent? That's the goal of this lesson. So we have this tracer. I'm going to go ahead. I'll just rerun these just for clarity, but we have a SQL generation tool. So this is going to take an input query and turn that into a SQL query. So it's going to take like a natural language and turn that into a SQL query. That's the goal of this tool, and that's what the logic is here. What you can do is then wrap that tool call or that function in this, in this sort of convenience function here with this handler, which can actually basically take all of the logic underneath that function call and make it an object that we can then instrument. So this is like instrumenting using these decorators. The second tool is data analysis. So once I've taken natural language, turned it into a question, can I actually interpret the data in some way? So this is basically, you can see the prompt here as well. Analyze the following data. So it's taking the data from the retrieval of the database and putting it into this prompt. And it's saying your job is to answer the following question, which was the natural language question that we're going to ask. And sort of last but not least, we have data visualization, which is create a chart based on that data. So again, you don't always have to use all of these tools, right? Like this is what you're sort of providing to the agent is options for it to decide, do I want to use A or B or C to perform a task? And so it is important to evaluate if I ask a question like, give me sales data from November, I don't necessarily need a chart for that, right? So this is an example where you want to evaluate, is the agent being efficient, calling the right tools? Okay, and then this is the actual like JSON construction of the function calls from before. Hopefully most of this should be familiar since you've probably done some tool construction with functions, and then you've actually created a function which is just basically this JSON object. Great, okay, and now we're gonna actually, and then this is basically the handling of the tools. This is sort of code to construct all of that together. And we're going to actually go ahead and run the agent. So we're going to use that same example. Which stores had the highest sales in November 2021? Run this through. And you can see that the process here is basically starting the main agent span, running agent with messages. So I actually sent it 2 questions. I said, which stores had the highest sales? And then I also asked it another question up here, show me a visualization. So let's see if it does that. So it basically goes and constructs and finds, okay, here is the total sales volume, and then here are the store's numbers. So it's giving me the actual information I wanted from my database. And then, okay, visualization code. Here is the visualization of sales data. That doesn't seem right. It looks like it's actually just saying attachment :// something.png. That doesn't seem like a visualization. Okay, let's keep going. What does that look like? So if I go into Phoenix, what I'll see now is basically our traces from the agent run. And I can click in and see that actually this is what all of the application code I just created is, right? So this is basically an agent taking that input and calling out to a router that basically determines I need to handle these tools and execute a SQL query to get back this data. And then I'm going to use another router call to construct the final response with that input information from before. So this is each step in that agent broken down step by step. And this is really important because when you're building agents, this is a really, really simple example. Like if you and your teams are building agents, they're going to get much bigger, more complex than this, especially if you're using your own logic, if you're using your own APIs. And so being able to see what's happening along the way is really the only way that you can reproduce and evaluate and go beyond vibe coding basically with your agent. Cool. So I would call that like the equivalent of just like spot checking your data, just making sure everything makes sense. It's like looking the way you expect it to based on your application logic. But we want to take this one step further, right? We're not vibe coding this agent. We're thrive coding it. So we're going to go ahead and evaluate it. And what we mean by evaluation is actually using LLM as a judge, which is a term some of you may be familiar with. But LLM as a judge is basically using an LLM to evaluate the output of another LLM. So you're giving it a prompt that says, check this other information and this work that this other tool is doing. So I've gone ahead and set up this evaluation agent, and I'm going to go ahead and basically run this function calling eval. So the function calling eval is going to take my data from Phoenix. So it's actually exporting the data from Phoenix. I'm running this all real time, and you can see it's actually calling. I've constructed this query here where it pulls out all of my tool calls. So if I go back in here, you can see there are these tool calls, and these are tool call spans. And it's basically constructing a data frame of these tool calls. And the reason for that is because we're going to evaluate were these tools correct. What I'm then going to do is then use this. Actually, let me just go ahead and run this, show this to you guys. Live demo. So let's see if this works. Okay, so this is the tool calling prompt template. You are an evaluation assistant evaluating questions and tool calls to determine whether the tool would answer the question. So what I'm doing here is actually using a package called LLM classify, which takes that data frame we just pulled out from Phoenix and calls this tool calling template. And we have some off-the-shelf templates, but you can really think of this as anything. You can write this to be whatever you want for your agent. It can be super specific to your business. It can be things like, don't ever answer with my competitor's product, for instance, as an example. And then I'm giving it rails here, which are correct and incorrect. This is really important because a lot of times some folks who are trying to evaluate with LLMs, they'll try to use scores, which LLMs hallucinate numbers a fair deal. And so you want to give it specific terms or words that are grounded. And so correct and incorrect are the rails, and then I can provide explanations. So let's go ahead and run these evals on the data that we just generated. Okay, so that should have run, and I've got here another data frame of correct label here, correct and incorrect, and more information. And I can actually log that back to Phoenix. This is 2 lines of code here, log evaluations back to Phoenix. Great. Let me refresh the page. Awesome. And now you can see at the top here, we have evals. We have a tool calling eval. It looks like my agent is performing tool calls about 80% correctly. Let's go in and figure out what's going on here. So I can click a specific example where the agent said the tool call is incorrect. I think we all saw that, which was trying to produce a visualization, and it just spit out like a PNG that didn't exist, right? So like the agent actually tried to use this tool, and it didn't actually produce a visualization correctly. And that's what the LLM as a judge said as well. It says the user requested a visualization, but it didn't actually generate the visualization. It didn't do it correctly. So that's great. I mean, imagine if you scale this up to hundreds or thousands of rows of data. You can now see consistently which tool calls are breaking the most. And so that's really important as you're trying to figure out how to iterate. Okay, so that was the first part of this workshop. We went through that quickly. We're going to jump into eval prompting next. We're going to see how far we can get here. So this is prompt optimization for the eval template that we just used. So you guys saw the tool calling prompt, which is, look and evaluate this. But that got us a pretty good response, but I think we can do better. I think we can improve that eval prompt with a few different techniques we'll talk about. If any of this seems interesting and you want to chat about it more, we will be at our booth after this as well. That's Arize. We're kind of near the front, and then also happy to chat about any of this afterwards. Great. So what do we mean when we're saying techniques for prompt optimization? So we're going to cover a few techniques here. This was actually sort of a Twitter thread that our head of developer relations, John, put together of kind of 4 very common techniques for prompt optimization. And our goal here is, again, not to hand wave this and say, is my prompt getting better or worse? You want to use data to actually validate empirically, are these things actually moving the needle for me, or do they just sound cool, like gradient prompt optimization? So we're going to go in and do that. The first one is gradient prompt optimization. This is basically using embeddings to tune the loss function and improve prompts using embeddings, essentially. It's really useful for longer, complex prompts where you can generate really specific embeddings in this embedding space. Let's go ahead and run that now. So we saw that tool calling prompt. This is what it looks like. What I can do is, what I'm going to do is actually set up, I have a data set here of more examples I generated before. Actually, I only generated a few of these. Let's see if this actually works. OpenAI, ChatGPT helped me generate more. So it's kind of synthetic data. So I've taken a few and I've used an LLM to generate more synthetic data of questions, the tool call, what did the LLM do, and then a label, either correct or incorrect. And then I'm converting that into a data frame that I can then use to upload it to Phoenix. And so Phoenix basically takes this data frame object and we call it a data set. And this is basically what you want to use for iteration. So I just created this. You can see the timestamp here, the top one. And if I zoom in, this is the same data set I just showed you in code. The reason that this is important is because when you're taking production data or you're using data for development, you want a way to be able to version, maintain that data in a central place. So think a very common term is like golden data set. This is where you would store your golden data set. Great, so I've uploaded that to Phoenix. And I'm going to go ahead and this is my test prompt function call. And I'm going to go ahead and just run a baseline evaluation on this data set. So this is going to take that same data and run the evals on it. So I'm just generating evals to start off with as a baseline. It runs pretty fast. If you give it more data, it might take a little bit longer. But let's see. So it's basically going in, and there's an LLM as a judge going in and labeling that data. So what did we just do here? So what I did was I took that base prompt and I ran it on this data set to get a score for how is that base prompt doing on the data set. And it looks like it's only about 68% accurate relative to the labels that I gave it before. So that means that there's probably some amount of room for improvement here on that base prompt. So we're going to do few-shot prompting to start off with. I guess I should have jumped into that one first. Few-shot prompting is basically stuffing in a couple of examples in the prompt. This does increase the context window, but you're basically saying, here are examples. Here's the instruction, here's the definition, and then the examples are user prompt and labels. Use these to basically make decisions. This was actually, I think, the previous speaker kind of also mentioned, like, you want to kind of have like specific determinism. This is sort of like giving it determinism through the context. Okay, so we're going to run that first and test this new prompt. And now I'm running an experiment where I'm actually running this new prompt where I'm pulling in some data into the prompt itself. And that's what the evaluator is doing right now. So it's actually using data to evaluate as examples in the prompt. All right, wow, that's pretty good. So I'll just go ahead and refresh the page. You can see that we've gone from 68% to 84% just by giving a couple of rows of data. This is like 3 or 4 rows of data. But the good part here is like I'm showing you numbers as opposed to just saying like looks good to me. So that's really the main takeaway is you want to be able to measure the impact of the work that you're doing when you're iterating on your prompts. Awesome. The next one is meta prompting. So meta prompting is basically using, and sort of think of this as like writing an improved prompt based on, saying, look at the previous prompt and say, you are a prompt engineering expert. Take these examples and write a new prompt. So it's sort of few-shot prompting plus an LLM is one way to look at it. So you're sort of saying, write me a new prompt based on the examples before. So you can actually ground it with more specificity as well. So let's go ahead and try that. You are an expert prompt engineer. Here's a list of examples. And it wrote me a new prompt. You are an evaluation assistant tasked with assessing the appropriateness of tool calls. Okay, some new words here, but maybe this is going to perform better. I'm not sure. We'll see how it does. And then we're going to run this and actually rerun the experiment again. And so what I'm doing every time I'm running the experiment is taking that data set, taking this new prompt, and using that to generate labels consistently over time. And that's all the experiment is it's rerunning the LLM, basically this new LLM I've created. Give it a couple seconds to run. All right, look at that. So refresh the page. I've now gone from 68% to 84% to now 88% improvement. So that means that if I actually use an LLM to prompt engineer and give it specific examples, it seems to be performing better. Again, your mileage may vary. It depends a lot on the task, but the goal here is to be able to measure the techniques that you're using. Okay, I think we're coming up on one of the last ones here, which is DSPy. So DSPy is a package I think many folks might be familiar with. This is actually using, I'll go ahead and jump in here. This is actually using a prompt optimization library. Basically think of this as sort of training a classifier, like taking a lot of the traditional ML approaches to go ahead and basically write prompts. So it's sort of interesting, like when you look at the prompts from DSPy, they don't, and we're also using, I should say, MIPRO as the approach here. So the actual improvement. And what's interesting is like, it'll actually go in and take that data set and run multiple iterations to write a new prompt. So it's bootstrapping and running the new prompt. And it's going to write proposing instructions. See how it does. Might take a second. We may or may not get to actually being able to run this one. Oh, okay. Okay. We might need to come back to DSPy in a little bit because it does take a second here. Almost there. Okay, so it ran the optimized prompt and now it's running the eval on that prompt. It actually runs really fast too. I think that's one thing I've noticed. And it looks like it's giving me a faster result, at least the evaluation ran faster, the task ran faster, so it optimized the prompt for speed, but it didn't look like it significantly moved the needle on my evaluation. So the goal here, I think, hopefully just to wrap up is, basically we want to give you the tools to be able to trace, instrument, understand your agents as you're building them, but also give you the tools to be able to iterate and evaluate the improvements that you're making. So yeah, if you liked any of this, we'd love to chat with you. Phoenix is open source. We'd love a star. And yeah, feel free to join our community for any follow-up questions. Thanks all.